In the next 24 hours, over 1,200 robots will build an electric car from scratch. No coffee breaks, no mistakes, just perfect precision. You're about to witness the most advanced manufacturing process on Earth. This isn't science fiction. This is happening right now in factories across America and the world. By the end of this video, you'll understand exactly how these mechanical masterminds work together like a symphony orchestra. Welcome to Robot World, where we explore the future being built today. I'm taking you inside the most automated electric vehicle factory ever created. Hit that subscribe button, because what you're about to see will change how you think about manufacturing forever. Today, you'll see stamping robots that shape metal like clay, welding machines that never miss a single spot, AI-powered vision systems that catch defect invisible to the human eye, and the exact moment when metal becomes mobility. This facility spans over 5 million square feet. That's nearly 100 football fields. Every day, trucks deliver raw materials at one end and finished electric cars roll out at the other. Let's step inside. The first thing you notice isn't the noise, it's the choreography. Over 1,200 robots moving in perfect harmony, never colliding, never stopping. This is automation at a scale that would have been impossible just 10 years ago. Before a single robot moves, everything is planned here. This central AI system coordinates every robot, every tool, every movement. It's like the conductor of an orchestra, except this orchestra builds 1,000 cars per day. Our journey begins with raw aluminum coils, weighing up to 5 tons each. These self-driving vehicles, called AGVs, transport them to the stamping area. No human drivers, just sensors, cameras, and precision navigation. This is where metal meets force. These stamping presses can exert up to 2,500 tons of pressure. That's like stacking 500 elephants on a single sheet of aluminum. And they do it 15 times per minute. Watch this. In just 3 seconds, a flat sheet of aluminum becomes a car door panel. Perfectly shaped, zero defects. The press is so precise. It controls pressure down to the millimeter. This is how modern car bodies are born. Immediately, a robotic arm picks up the part, still warm from the press. Temperature sensors ensure it's cooled to exactly 85 degrees Celsius before moving to the next stage. Too hot, and the metal could warp. Too cold, and the process slows down. Now we enter the body shop, the heart of the factory. This is where hundreds of metal parts become a single, unified car body. And the workers here, almost entirely robotic. These orange giants are spot welding robots. Each one can perform 120 welds per minute with absolute accuracy. They're placing 5,000 welds on a single car body, and every weld is identical to the last. Look at this precision. The robot positions a welding electrode with an accuracy of 0.1 millimeters. That's thinner than a human hair. At this speed and accuracy, no human hand could ever compete. Here's where it gets fascinating. 6 robots are working on the same car body simultaneously, from different angles. They're communicating with each other 1,000 times per second to avoid collisions. It's a metal ballet. In just 90 seconds, what was once 300 separate pieces of metal is now a complete car body frame. Strong enough to protect passengers, light enough to maximize range. This is engineering poetry. Before this body gets its color, it needs to be perfectly clean. Even a speck of dust could ruin the paint finish. That's why it enters a fully automated cleaning chamber next. Robotic nozzles spray high-pressure deionized water from 47 different angles, removing every particle of oil, dust, and debris. Then, the body is dried using precision air jets. Not a single water spot remains. Welcome to the paint shop, the cleanest room in the entire factory. The air here is filtered 60 times per hour. Why? Because these robots are about to apply paint so thin, it's measured in microns. Each painting robot holds a spray gun that rotates at 40,000 revolutions per minute. They apply 5 layers of paint. Primer, base coat, color coat, and 2 layers of clear coat. Total thickness? Just 120 microns, about as thick as a single sheet of paper. The robots adjust spray pressure, distance, and speed in real time to ensure perfect coverage. No runs, no drips, no orange peel texture. Just a mirror-smooth finish that will last for decades. After painting, the bodies enter these massive ovens heated to exactly 180 degrees Celsius. They bake for 30 minutes, curing the paint into a rock-hard shell. Then they're cooled gradually to prevent cracking. Here's where AI takes over. These vision systems capture 10,000 images of the painted surface, analyzing every millimeter for defects. A human inspector might miss a tiny flaw. These cameras never do. While the body was being painted, something crucial was being built in a separate section, the battery pack. This is the heart of an electric car, and it's assembled with extreme precision. A single electric car battery contains over 4,600 individual cells, each about the size of an AA battery. Robots arrange them in precise modules, connecting them in series and parallel to create the right voltage and capacity. Every single cell is tested before installation. Voltage, capacity, internal resistance, all measured in milliseconds. A single bad cell could compromise the entire pack, so nothing is left to chance. This is called the marriage line, where the car body meets its powertrain and battery pack. It's one of the most critical moments in the entire build process. The battery pack weighs over 1,200 pounds. A team of 4 robots lifts it with synchronized precision, sliding it into the car's floor pan with just 2 millimeters of clearance on each side. Perfect alignment every single time. Next comes the electric motors. This vehicle has 2, one for the front axle, one for the rear. Together, they produce over 600 horsepower. The robots bolt them in place with computer-controlled torque wrenches. Suspension components, brakes, and wheels come next. Each lug nut is tightened to exactly 140 newton meters of torque, not a single degree more or less. This precision prevents wheel wobble and ensures safety. Now the car starts to look like a car. The dashboard, complete with its massive touchscreen, is lowered into place by a robot with suction cups. It's positioned with millimeter accuracy, so every button, every vent aligns perfectly. The seats arrive on automated carriers. Collaborative robots, called cobots, work alongside human technicians to install them. These cobots can sense human presence and slow down or stop to prevent accidents. An electric car contains over 3 kilometers of wiring. Every wire, every connector must be placed exactly right. Robots guide the harnesses into place. Then human technicians make the final connections and verify them. Watch this robot install the windshield. It applies a precise bead of urethane adhesive, then positions a glass with suction cups. The margin for error? 0. The windshield is a structural component that adds rigidity to the entire vehicle. Here's something most people don't realize. A modern electric car has over 100 million lines of code, more than a Boeing 787 Dreamliner. All of that software is being uploaded to the car right now. This is a magical moment. The first time this car receives power, the dashboard illuminates, systems boot up, and the AI begins initializing. It's like watching a mechanical brain wake up for the very first time. This car has 12 cameras, 8 radar sensors, and 16 ultrasonic sensors. Each one must be calibrated to millimeter precision. The AI uses this data to create a 360-degree view of the world for autonomous driving features. The cameras are calibrated using these special targets. The system measures angles, distances, and focal points, then programs the AI to interpret what it sees. This process takes just 90 seconds, but is critical for safety. Now comes a moment of truth. The car is placed on this roller dynamometer, essentially a treadmill for cars. The electric motors are powered up, and the car accelerates to 80 miles per hour without moving an inch. During this test, sensors measure acceleration, braking, power output, energy consumption, and regenerative braking. Every parameter must fall within exact specifications. If something's wrong, the AI flags it immediately. Next, the car enters a simulated monsoon. Nozzles spray water from every angle at pressures equivalent to a Category 3 hurricane. If a single drop gets inside, sensors will detect it. These AI-powered cameras are performing what's called a digital twin inspection. They're comparing this physical car to the perfect digital model, measuring every gap, every panel alignment, every surface finish. But even with all this automation, human expertise still matters. These master technicians perform the final quality audit. They're checking things robots can't easily evaluate. How doors sound when they close, how switches feel when you press them. This is the future, not humans versus robots, but humans and robots working together. The robots handle the heavy, repetitive, dangerous tasks. Humans handle the complex decisions, quality judgments, and continuous improvement. Automation has eliminated jobs. It's transformed them. The workers here aren't assembling parts anymore. They're programming robots, analyzing data, solving problems, and innovating. These are high-skilled, high-paying careers. After 22 hours and 45 minutes, our electric car is complete. But before it can leave the factory, it faces one last challenge: the final inspection station. Every electrical system is tested simultaneously. Headlights, charging port, climate control, entertainment system, safety features, everything. This final check takes 15 minutes and involves over 2,000 individual test points. 23 hours and 58 minutes after the first piece of aluminum entered the stamping press, a fully functional electric car rolls out of this factory. From raw metal to smart machine, all in less than 24 hours. This factory produces one car every 86 seconds. That's over 1,000 cars per day, 365 days a year. In the time it took you to watch this video, 10 new electric cars were born. This is more than manufacturing. This is the foundation of our sustainable future. Every car built here produces zero emissions, uses renewable energy, and brings us closer to a cleaner planet. The robots aren't just building cars, they're building tomorrow. If this look inside the future inspired you, hit that like button and subscribe to Robot World. Drop a comment and tell me, which part of this process amazed you the most? Was it the welding robots, the AI quality systems, or something else? And if you want to see how robots are building the future in other industries, let me know. Should we explore how robots build smartphones, construct skyscrapers, or even perform surgery? Your comments decide our next journey. Remember, the future isn't something that happens to us. It's something we build together, one innovation at a time. And you just witnessed how 1,200 robots and human ingenuity are building it. 24 hours a day, 365 days a year. The future is electric. The future is automated. The future is now. Thanks for watching Robot World. Until next time, keep exploring the machines that are shaping our tomorrow.